Hello, and welcome to the recap of the programming course for the week of April 28th. So during this class, we kind of did a couple different things. We recapped the end of year expectations, talking about some changes to third grading policy and what we're going to look forward to in the fourth quarter. And then we also took a look at the robot labs. We actually did some coding for Lab 00 and Lab 01. So let's just jump forward and talk about the changes for the end of year. So there have been a couple changes in the grading policy since the last time we met. You have until May 1st to complete the third quarter work. So that's been extended for a week. So this is due on Friday. May 1st will be on Friday. And that's the deadline for getting all your third quarter work done. That is the polymorphism and inheritance labs on Codecademy. That was the last stuff that was required of you. All right, so in terms of fourth quarter, that's going to be the robot labs. The robot labs are all going to be in fourth quarter, and that's really all we're doing. We're not doing any kind of reflection questions, or we're not doing projects per se. We're doing the robot labs. They're all going to be graded on a 3-tier scale. So proficient, and that's anything that you do that's 80% correct, right? What is deemed to be above 80% would be proficient. Attempted would be anything between 1% to 79% correct. So some major errors that you have in your code would get you an attempted. Not attempted would just be if you don't even try it, you just kind of don't have anything done. And these are all going to be fourth quarter grades. These can only boost your overall average for the first 3 quarters. So this is not going to factor into the average in any way. All it does is we take your average, we figure out what your grade is, and then we decide, okay, are we going to move that up at all? And so you can get up to 2 grade distributions bump. So a grade distribution is from like a B to a B plus. A B plus to an A minus, that would be 2 total, all right? So in order to do that, there's some little bit of gray area, and then there's some clear-cut examples. So if you get 6 or more proficient labs, you're gonna be considered for a 1 grade distribution bump, all right? And so that consideration is gonna be, have you been coming to class? Have you been coming to office hours and asking questions, participating? Have you been sending me emails with questions and concerns, trying to get that extra help to get these labs done? Do I have proof? Do I have some kind of thing that I can point to and say, yes, this student has been working hard, that I can use as a justification for giving you that grade distribution bump? And that's 6 or more labs at a proficient level. I'll start considering whether or not I want to boost your grade up by 1. All right, in order to get kind of a guaranteed grade bump up is to complete a minimum of 8 labs proficiently. Now Lab 00 and Lab 01, they're not really going to count too much because we're pretty much going to be walking through them together. Lab 00, there's nothing to do. So we'll talk about that once we get into the grading part. But if you get 8 or more proficient labs, then you're going to get that 1 grade distribution bump. In order to earn 2 grade distribution bumps, you're going to need to complete 14 or more of the labs. And there are a total of 15. So if you get 14 or more done by the end of the school year, June 12th, then you will be given a 2 grade distribution bump. Now, on Google Classroom, there are some assignment due dates. Again, there is no late work that's going to be counted. We're not going to count any late work, I'm sorry. There is no due date, hard due date. It's all going to be accepted. Those due dates are kind of suggestions and some kind of pacing that you can use to kind of pace yourself to get through the work by the end of the year. But you do not have to follow that. If you turn in Lab 6 on June 11th, then that's That's what you have, and that's okay, right? There's no nothing that has to be done by a certain time besides that June 12th deadline to have everything turned in that's going to be graded. I'm not going to take anything after June 12th, but otherwise everything will get full credit. I'm not going to dock you anybody any points. If they turn something in on June 11th, you'll still get credit for it. All right, so those due dates, again, don't matter. All they are suggestions for you to be pacing yourself to get through all the material by the end of the year. Okay, so we'll move on now to kind of talk about office hours and what to do. So all my office hours are going to be held through Blackboard Collaborate. You have a link for your individual class, but I also have a session called Office Hours that I have, and it's open all the time. You can't do anything in there if nobody's there. There's no audio, there's no video, there's no chat features or anything, but it's open and it's the single link, so we can go in there at pretty much any time and do work with students. So I'll be in there on Wednesdays from 2:30 to 4. I'll be in there Fridays from 9 to 10:30, and I'll be in there sporadically throughout the day and throughout the week at different times. If people email me and they want to set up an appointment to get some extra help on labs or to talk through any problems they're having with the programming or the robot labs, just send me a quick email. We'll schedule a time, we'll go in and we'll get some work done. And so I'm not sending out that link to everybody at once because not everybody's going to use it, and it takes a really long time to produce and generate all of those links for everybody. So if you need a link and you haven't gotten one yet, just send me a real quick email. I'll type your name in, I'll send you the link, and then you can use it. But again, I'm only going to send that out to people who ask for it. And again, to do one is relatively quick. So if you send me an email, I can generate it for you and we can use it as needed. All right. But those are the office hours. Again, I'm available pretty much anytime. If you email me the day before, should be able to accommodate whatever kind of schedule you have, as long as I'm not already teaching or not already working with another student at that time. If you want to schedule a time for the same day, that's possible. I would say just send me the email, see if we can get it set up, but I can't guarantee that I'll be able to meet the same day. But I do check my emails often, so if you send it, there's a good possibility. All right, so that's pretty much it for that. Let's get into coding and let's start looking at Lab 00. All right, so again, you should have been able to access these labs via the Google Classroom and download them. Make sure you save them onto that folder that's on your desktop. And Lab 00 is already a fully functioning lab. You shouldn't have to do anything to it except to open it up and run it. I do want to talk about a few things that you see in this lab, and we'll kind of go through that, and then we'll do a little bit of coding for Lab 01, and we'll kind of walk you through that first initial part. All right, so the first things here I want to talk about is just right up here, this first line, number 2, where it talks about public class Lab 00. Again, this first thing, public, here just talks about its visibility. And you know, there's different levels of visibility. Public is the most accessible, so it's open to any file that has the correct class path to find this. So it's pretty open, pretty accessible, hence the name public. All right, you do need class here if you're going to create a new class of file. And then classes are always use uppercase letters to start, right? So you should capitalize the first letter of any class. And again, it can only be one word or one set of strings, symbols here. It has to start with the letter. You cannot have any spaces in it. So it needs to be like this. If you put a space in here, if you put lab space 00, it's going to give you an error. So just make sure that it looks like that. All right. Down here, we can see our first method that we're creating. And any method, or sorry, any class file that's going to be executable, and it's going to be something that actually runs. So you're going to use the running man here to run the program, needs to have a main method to be able to run. All right. And most of these that we're going to create are going to have a main method in it. Some of the objects that we create may not, but most of our labs, anything that's labeled lab 00, lab 01, lab 02, all of those are going to have a main method. And our main methods are always going to kind of look the same in this declaration. All right, this declaration statement should always be starting with public. It should always have the word static, should always have the word void, should always say main, and then it should have a string array arg inside the parentheses. All right, so let's just talk a little bit about what this means. We've talked about public already. So static here refers to a method that does not require, it's not going to fit. An instance of an object to call the method. All right, so the method belongs to the class. All right. Now there are a different type of method called an instance method. Instance methods require an instance of an object. This uses what's called dot notation. Okay, and let's just make this a little smaller. Okay, so hopefully that's still readable. So instance versus static, and we can see kind of down here, we'll talk a little bit more about that in a minute. So this word void here, void, this is a return type of nothing, if you remember this. Void methods do not return anything. They kind of exist out on their own. They don't need to be in an assignment. They don't need to be in a conditional. They're just kind of out there. They do stuff without returning any type of information back to another line within your code. So voids are return type nothing. All right. And then again, main is just going to be the name of your method. And it needs to match, right? The capitalization needs to be correct. The spelling needs to be correct. It has to match because that's what it's looking for when the compiler runs the program. It's looking for that main method. So if you had something else here, it's not going to find it and it's not going to run. Inside of the parentheses, remember that all methods, right? All methods have parentheses at the end, right? So main has a set of parentheses, so it's a method, right? We always know that it's a method because it ends with parentheses. If there's no parentheses, it's not a method. So be careful when you're doing that. The things that are inside the parentheses are called parameters. Parameters are arguments or bits of information that the method requires in order to run properly. So we call that a parameter. So it's the required information that a method needs to run, right? Some methods don't require any information to be provided, and those are called no arg, right? Zero arg or empty arg parameters, but some methods do require things. So this main method requires a string array, right? So the first thing here kind of is an identifier of a type, right? So what type of information has to be provided? The second thing here is an identifier name, some way to reference that piece of information within the method itself. All right. So, and when we create, we'll talk more about this when we create some additional methods. All right. So when we get down here to setting up our world, right? The world is an object that's been pre-created for you. The world is that little panel that pops up, and it has size and speed, and it has an ability to have different designs in it with beepers and walls and mazes and things like that that the robot can kind of navigate through. So there's been some worlds that have been created for you. And so the world object was created itself, and we designed some methods already. Some of the methods that the world object has is read world, set size, set speed, right? And then you see some of the parameters that are here. Now, just to kind of talk a little bit about this read world method. From the way that this is written here, right, where it says world.readWorld, parentheses, quotation, begin one, close quotations, close parentheses. I know something about this, right? The fact that it's all by itself indicates that it is a void method, right? The fact that I'm calling this object world in this program, lab 00, without creating any world, right? I didn't create a world anywhere in this lab. So that means I know that it has to be public, right? The world object, the class file that it exists in, has to be a public class file. Otherwise, I couldn't access it. Now, it's the read world method, right, is being used and being called with dot notation, right? This is a method that belongs to a specific world. So I know that it is non-static, right? It is a non-static method. And we can talk about instance methods, another way to kind of refer to these as non-static. And just kind of get our spacing here. So instance methods are non-static methods requiring an instance of an object to call the method. Uses dot notation. And there's no indication for that. There's no word that we use to fill this space here. We just leave it blank. Now the fact that this world.readWorld is all by itself, there's no assignment, there's no condition, right? There's nothing there, it's not in a loop. I know that its a return type is void. So I know that this is a public void. I know that its name is read world, and it's a method, so I know that there's parentheses in there. Now I know that it takes a parameter because I see the parameter right here. The fact that it's in quotations tells me that it's a string. So again, parameters, when you're defining a method, you have to tell it what type of information you're going to provide it. So I'm going to provide this method with a string, but then you also need to provide it. You also need to provide it with a variable name, like an indicator, so that I can refer to that, a reference name, so that I can refer to it later on in the method. So, you can do anything here, like maybe file name, or you could call it world name, right? Something, whatever you want to call it here, it's just a placeholder. But whatever you put there, you're going to kind of use that throughout the actual method when you're defining it. So again, you should be able to look at something that's written in the code, and you should know certain pieces of information about that line of code just by the way it's written. All right, so I know here that this set size actually takes two parameters because it has two integers in there, right? There's a 10 and then separated by a comma, another 10. So each parameter, you separate parameters from each other with a parenthesis. So I know that the world.setSize, right? If I was to be writing world.setSize, I know it would be public. I know it would be a void method. And the set size, it would take an int, and maybe we'll call this one street, and then int avenue. And this might make sense to you later once we get into the code. But I know that it takes two integers, and so you see I declare what type of variable, what type of data type it's going to require, what type of parameter, and then I give it an identifier, a reference name that I can refer to it as I create that method code down here that gets called within the driver program. Okay, so again, these are some kind of method statements that declare the method and give you some information, and you need to be able to see the connection between how it's used and how it's written and developed. All right, so down here, these three, let's just finish up with this real quick. These three statements here are all necessary when you do these robot labs. You're going to have to tell me what world we're working with. You're going to have to define the size of that world, and then you're going to set some speed, right? How fast is the robot going to operate throughout the world, right? And this information, the first two, will always be provided to you in the lab documentation that was provided on Google Classroom. The set speed you can kind of play with to see what's right and to get a feel for how you're coding. This can change. It depends on what you're trying to do. 7 is a good speed. It moves through the world at a speed that you can see everything that's happening. It's not very fast, but it's also not too slow. But you can slow it down if you want to kind of focus more on each step. If you're trying to figure out where you're going wrong, 7 I think is a pretty good speed. If you're just kind of trying to see if it can make it all the way to the end and do everything right, some of the longer programs you're probably going to want to set up to like a 12 or something like that. At 12 or 13, it can kind of move through the world at a pretty good speed, and it's not going to be too monotonous for you to watch. But again, there's all kinds of values in between that you can set it at and just figure out for yourself what you want to do. All right, so creating robots, creating instances of robots. This robot object has already been defined and created. It was one of the files that you downloaded from Google Classroom. I invite you to take a look at that file. Don't change anything from it. And if you do by chance break it by changing something that you can't figure out how to change it back, you can always re-download the file from Google Classroom. But there's no need to ever change anything within the robot class itself. But there's some interesting stuff in there that you might want to take a look at. But there's also a lot of really complicated stuff that you may not quite understand at this point, and you don't need to, okay? But if you want to kind of develop some more advanced skills and you want to take a look at what's happening in a robot, feel free, it's there. All right, so let's talk more about what you're going to actually do. So anytime I want to create a robot, I need to declare what type of thing I'm creating, right? I'm creating a robot object. You need to give it a reference identifier, right? And then you need to assign it some value, all right? So this new special word or reserved word in Java indicates to the computer that you're creating a new object and that some memory space needs to be allocated. And so it just indicates, get ready to allocate some new space for this thing I'm going to create. And then the second thing here is a method. You can tell because it has parentheses. And this is called a constructor method. Constructor methods are, you usually use them when you create objects that will give the object some predetermined information and different data types and methods that it's going to use when you use the robot or use the object. So sometimes there's parameters, sometimes there's not. Depends on how many constructors that object has defined for it and which one you want to use. In this case, we're using the empty arg or the no arg constructor for the robot. So in that case, we can talk about robot, open and close parentheses, an empty arg constructor. We'll put the robot at 1, 1 with, it actually goes facing east with 0 beepers. All right, so the order that it goes in is kind of important. When you're using the empty one, it doesn't matter, but these are the 3 parameters, or sorry, the 4 parameters that are determined. And then, so these kind of street, avenue, direction, and beeper count. All right. So if I wanted to create another robot, right, you could create a second instance of a robot. You can make as many robots as you want to make. You could have a whole robot army, and we'll talk about that later, how to create the robot army to bring on the apocalypse. But for now, we'll just start with making a new robot, Pew, and we're going to set it equal. It's going to be new, and we're going to use the robot constructor. However, we're not going to be using the default or the empty arg constructor. We're going to put it someplace. So I can say, let's put it at 5, 6, and let's change its direction. So I want its direction to be a different direction from east. So I'm going to say north. Now, so a couple of things here, and let's say we're going to have 5 beepers. Okay, let's say 4 beepers, so we're not using any numbers more than once. Okay, so 5 and 6 should be relatively easy to understand. They're the positions it's going to be on. The world.north, this directional status, it requires the world object. So the world object has some data fields, some things that have been defined for it already. And direction is one of those things that we defined within the world. So I got to call that, that data set from the world object. And since it belongs to the world object, I use the dot notation. What comes after it, you notice, hopefully you notice that it's all capital letters. All right. So what we have is when we use a variable, right? So if I can type, so variables are in camel case, all right, where the first letter is lowercase, and if it's multiple words, the subsequent words are all capitalized, the first letter. So camel case capitalization, you see there's 3 words, so the second and third word are uppercase, the first word is lowercase. But north doesn't follow that because the north is actually a constant. So constants are things that do not change. So what it means to be north is final. It's not going to be changed. There's no way to change it from outside of the world object class. So constants are final and don't change. We call that immutable. So we use all caps. All right, so again, that's how you can kind of tell when something is a constant, is you see it in all caps. Now notice north does not end with parentheses because it's not a method, right? This is just a data field that doesn't change. So there's nothing, no method happening going on here, so no parentheses. So dot notation, but not a method. And then we just have this beeper type here, or beeper number 4, all right? So now I have 2 robots, and here you can see that this move method is being called with the Carol robot is moving, okay? And you should be able to tell me what this move method looks like, how to instantiate it, how it was created. Again, this robot was not created in this class, so its accessibility must be public. It's being called by an actual instance of a robot, so it's non-static, so I'll just leave that out. And it's not an assignment, so it must be a void type, and it's called move, and there's no parameters. So that would be how you create the move method, right? That's how public void move is written in the robot, all right? Now, here's why you use different indicator names for different robots, because if I want Carol to move, I say Carol move. If I want the other one to move, I say pew.move. And so the first command here, line 18, will move the pew robot, and this Carol.move will move the Carol robot. And we'll kind of go through here. So one thing I want to kind of show you is how to kind of work the debugger. So if I put a little dot here on line 18, and then I hit this bug button, it's going to bring up the window to show us, and I forgot to put a semicolon. Remember to always end your executable lines with a semicolon. So now I'll push the debugger button, and it compiles. Notice I didn't compile it. All I did was start it off and just by hitting the debugger button. So this compiling button will check for errors, but it won't actually run the program. If you hit the run button, it'll actually run through the whole program. It'll compile first, then it'll run through the whole program. The debugger button will compile, and then it will run through the program until it runs into that red stop sign looking thing that I put up there. So you see it's created the world, it set the size, it set the speed, and then you can see it created this little world here. So if you look at our robots here, create and move, you can also see down here in run IO, it kind of tells us what's happened so far. So the first thing it did was create robot 00 at 1, 1 with 0 beepers facing east. That's Carol, all right? Because we used the empty arg. Now robot Pew, it gave me 5, 6, world north, and 4. But notice down here what happened when it displays. So it displays it in a slightly different way than how it's typed in. So your street is 6, which is your second value. So streets are actually, they run horizontally, but they are counted vertically. So 1, 2, 3, 4, 5, 6. So I'm on street 6, that's my vertical positioning. So the nice thing is that this 5, 6 reflects the way that you think about a coordinate plane in other math classes. This is your horizontal positioning, this is your vertical positioning, but how they display it is a little different, right? They have them a little backwards. So streets are numbered up and down, but they run horizontally. Avenues are numbered running across, but they run vertically, right? So it's a little confusing. And then beeper count, and then your direction. All right, so back to the debugger. It stopped here on 18. If I wanted to move forward, I just hit this down arrow, and you see that Q is now moved, and now Carol has moved. And you see down here, once Q moved, he moved up, so his street number increased. Carol moved over, so her avenue changed. So what's the difference? Why did one move method change the street and the move method called with the other object change the avenue? And it all has to do with the direction that they're facing in. You see the little head here is the direction. So move has them progressing in whatever direction they're facing. So, and that's all written within the robot code of ethics. No, not the code of ethics, the robot code of programming. So you can keep moving through here, and you can see Carol's moving down the code. We get here to this turn left, and you see her direction now changes from east to north. And we just keep progressing with the move. Now changes her avenue numbers until she gets to another move left, and then now she's facing, let's move that down, now she's facing west, and then we can just move her across, and now you see her avenues changes and goes down. She's sitting here on top of this beeper. When we call pick beeper, her beeper count increases from 0 to 1 because now she's picked up that beeper, and you see that the beeper no longer exists there. And that's the code for Lab 00, kind of walking you through it. And there is a put beeper, right, that will put the beeper right back down. And we'll talk a little bit about that in Lab 01. So I just wanted to kind of talk through this and give you a good feel for what all this stuff is doing, what it means, how to understand it, some key aspects that you kind of need to keep in your mind as you're coding this. So Lab 01, when you get started in this, I kind of gave you a little bit of a shell here. You need to create this yourself by going to File, New, Java. If you're running this for the first time on your computer, it may not be there, but you can go to Other, and if Java isn't already one of your types that are here, you can go to Other, and it'll be in this list here. All right, so Java, and you create a new one, and then you can do this. You can put the comment code here with your name and the date. Then you can create public class Lab 01 with your main method. Make sure you're putting your curly braces to start and end the lab, start and end the main. Within that, you're going to create your world. All right, remember there are 3 statements that you have to do. You have to tell me the world dot read world. Remember that's camel case. So read world. So open up your parentheses, and we are going to use quotations. And we're going to use the beginner world. Make sure you end that with a semicolon. And then we're going to set the size, and we'll say 10, 10. Right? Now, the last thing we have to do is set the speed. Now, the order doesn't really matter too much. You'll probably want to read the world first, but it doesn't matter if you set the speed or set the size first. So you see, I can go in here and do world.setSpeed to whatever you want. Again, it doesn't have to be 7. It could be 10. That'll make the robot move a little quicker. but it could be any number you want. 7 is slow, 12 is fast, like 7 is about medium, 4 will be slow and monotonous. So create yourself a robot. You can pretty much call this robot whatever you want to call it, but just know you're going to be typing this name a lot. So you might want to go with something small like Joe. Now Joe, even though it's a proper name, it is a variable indicator. It's an object indicator. You want to make sure that you use a lowercase letter here for anything that's not an object or a class, right? Lab is a class, robot is an object, Joe is not, so Joe gets a lowercase j. And just be consistent with that. So remember, we have to use that word new to indicate we're creating a new robot. And we're going to start Joe at 1, 1, facing east with 0 beepers. So we've done that. You only need to create one robot right here. And then we're going to just kind of move Joe through. Now I'm not quite sure what Joe looks like or what the world looks like. There is a picture of it on the documentation, but if you want to see a nice picture on your computer, you can kind of create your robot and then just hit the run button. And what's nice about that is it pops up a world here, and you're going to be able to then use that to code the rest of your program with it. So I can just kind of look at that picture and say, okay, I need Joe to move across the screen. So just move forward, Joe, and it looks like he needs to move 1, 2, 3 spaces. So you could type that in if you want to practice your keyboarding skills. But if that gets kind of boring for you and you want to do it a little quicker, just highlight that, Control C, and then come down there and Control V and paste it in there. So once Joe gets to there, if you feel comfortable with what you're doing, you can kind of just keep typing, or if you want to see what happens, you can just run it. And then you'll see Joe, see that 10, right? At 10, you didn't see Joe do anything, you just see the result. But if we go back to 7 and we run it, then you can see Joe move across the screen. All right, so once we're here, what we want to do is we want Joe to pick up that beeper. So we'll say Joe dot pick beeper, open close parentheses with your semicolon. That'll pick it up. And then we want him to head north. So the first thing we want to do here is have Joe turn left. Once he's turned left, then we can have him move. And this time we want 1, 2, 3, 4 moves. So that should still be saved. So we'll give it 1 move, 2 moves, 3 moves, 4 moves. And then we will pick beeper again. And once we have that, we want him to turn right. Now the problem with these robots is they don't know how to turn right. They're like all NASCAR drivers. All they do is turn left. You tell them to turn left, they can turn left. You want them to turn right, they just don't know how to do it. So I'm assuming you're going to figure this out on your own. So I'll just tell you, if we want to turn right with a robot, we have to tell it to turn left, which it knows how to do. And then we are going to do that 3 times. If you turn left 3 times, you will be facing the same direction as if you turn right. And then we're going to make him move 3 spaces. So Control C and Control V. And once we get to the end, we're going to have Joe put down that beeper. So once Joe puts down the beeper, let's run this and see what happens. So there he goes, he picks it up, turns left, and he drops it off. But wait a minute, look at that. Joe still has a beeper in his hands because he picked up 2, but he only put down 1. So we're going to have to tell Joe to put the beeper down because he only does it 1 time even though he has 2 of them. So now that he's put the beeper down twice, he's finished. He'll have 0 beepers in his hand, and that will be the end of lab 1A. Now, this lab consists of a second part called lab 1B, which requires you to create a robot starting at 7.5 and progressing in the reverse direction. So you'll create a new file, you'll call it lab 01B. You'll change the code up a little bit to make him start at 7.5 and go in the opposite direction. So you'll use that other constructor like I showed you in lab 00 instructions. From there, you should be able to figure out most of everything else. Just again, make sure that you're checking the beeper count to make sure that they're putting everything down. And hopefully this was helpful for you to understand these labs and to get started. And let me know if you have any questions or concerns. Thanks for watching.